Lesson 11.2 operations with matrices. And so 11.1 was looking at what is a matrix, what does it basically look like, how do you read and interpret it. Okay, now we're going to start doing a little bit of math with it. What kind of math? So we can add or subtract a matrix from another matrix. Okay, that's okay. Yeah, here we go. Add and subtract. Okay. You can multiply by a scalar. Okay. Now multiplying a matrix by another matrix. Okay, is that's a story for another day. Right? But multiplying just by a simple number, right? Just like a simple factor number, that's not too bad. All right, and then okay, and then they got some multi-step operation example for example 3. Okay, so let's go through again here. What it got? You've learned in the previous courses that the sum of a real number and additive identity 0 is equal to the real number. For example, 5 plus 0 is 5. That's the additive identity matrix. Right. Okay, so if you I got an example down here. Here, move. Oh yeah, that's a little better, I think. Okay. All right, so if you had this matrix, they're calling matrix A, looks like 3, 7, 8, -1, and you add that to 0, well, it is itself. Okay, so okay, that's okay, no, that's okay. A matrix can be multiplied by a constant called a scalar. Okay, and that's we're getting into example 2 down there. We got scalar multiplication. All right, so let's do example 1. Add and subtract matrices. So example 1. Okay. 1A. Okay. We're doing A plus C, where they give matrix A to be this right here. We got 8, 9, 0, -3. And matrix C is given as right here. So that's 2, -2, 1, 5. Right? So what's that going to be? Okay. Well, all I have to do is add each element to each corresponding element. So like this A11 and this A11, well, those can go together. So 8 plus 2 is 10. Okay. 9 plus -2 is 7. 0 plus 1 is 1. -3 plus 5 is 2. So that should be the answer right there. Okay. Make sure that's what they got. Okay, they got the same process I just did right there. So that's of course going to be the same. Okay. Now notice that to add two matrices together, they do have to have similar dimensions. Like these are each 2 by 2 matrices. So you can do 2 by 2 and a 2 by 2 you can add together. Okay. Or if you had a 2 by 3 and a 2 by 3, that would also be okay. Okay. But I'm looking at matrix B right here, and this is a 1 by 2 matrix. So I don't think you can add B to anything. Yeah, that's probably what they're getting at right here. B. Okay, so they say, what is B plus C? You say, well, I know B is 3, -1, okay? And C is what we did before, 2, -2, 1, 5. Okay. All right, so you are not allowed to add these together. So I'll say no solution. Okay, because 1 by 2 and a 2 by 2, those are different matrices. Okay, so you're not allowed to add those together. All right. Okay. Here, I'll just point this one out. If they do C minus A, okay. Well, here's A and here's C. So what if I did C minus A? Yeah, I'll go ahead and write this one down. Let's do it. Okay. So what is C minus A? Matrix C, matrix A. Okay. Well, I remember C was 2, -2, 1, 5. Right, that's just that right there. Okay. And A was 8, 9, 0, -3. Okay. And I'm subtracting. Well, that's really just like that, isn't it? Minus. Right? Now, if you wanted to, you could think of it as distributing its negative to all 4 of these elements, or however you think of it. 2 minus 8 is -6. -2 minus 9 is -11. 1 minus 0 is 1. Root 1. And 5 minus -3. Isn't that 5 plus 3? Isn't that what that is? It's got to be 8. And so that should be the answer right there. Okay. And if you thought about this in terms of distributing that negative, that's actually a good segue to example 2. Multiply by a scalar. In that case, it would have been multiplying by -1. Okay. So let's do 1/2 g for g equals this matrix 11, 18, -3, -6, 48, 28, like that. Okay. So if I want to do one half of that, 11, 18, -3, 6, 40, 28. Okay. All I have to do is multiply each one of these elements by one half. So half of 11 is 5.5 or 11 over 2. Half of 18 is 9. Half of that is that. Half of that is that. Half of that is that. And half of that is that. There you go. And that's it. That's how you multiply by a scalar. Um, okay. Let's do this little track one down here. This one looks fun. Okay. So they're doing saying what's -3h, where h is, and let's go ahead and cut straight to it, is 2, -12, 5, 0. Go like that. Okay. Right, so I can matrix multiply -3 by each one of these pieces. So -6, +36, -15, and 0. There you go. There's the answer. All right, multi-step operations with matrices. Ooh, it looks like we're gonna get a nice story example here. So what is this? Laura plans to buy a variety of paint for her house. Ooh, let's see this. Paint for her house. The tables show the store brand prices and dollars for each sheen of paint, which comes in 1 gallon and 5 gallon sizes. Olson Decor is having a 10% off sale on all products, and Laura has a coupon for 15% off of her total purchase for Fresh Home. Okay, so we got Olson Decor over here. Maybe this is one store, a Fresh Home over here, a different store. Okay. And they each have 1 gallon and 5 gallon sizes of paint. Okay. And they have these different kinds of paint. They each have flat, eggshell, satin, semi-gloss, and gloss. There we go. Okay, so we got categories and prices going on here. Use matrices to find the price difference between Olson Decor and Fresh Home after the discounts and interpret the results. Ah, okay. I know what to do here. Right, so turn each of these here. Let's get this camera. Okay. We're going to create a matrix for each one of these. Okay. So Olson, maybe I'll call it matrix O. And Fresh Home, maybe I'll call it matrix F. Okay. And they said use matrices to find the price difference. Now, just at a glance, does one of these look more expensive than the other? Yeah, mostly. Okay. Looks like generally Fresh Home is more expensive than Olson Decor. So maybe I will rearrange it like that. I'll say the difference equals Fresh Home minus Olson Decor. And then I might end up with a couple of negative numbers, but mostly it'll be positive this way. Okay. And interpret the results. Okay, so this would say how much more expensive is Fresh Home than Olson Decor. Okay. Notice they haven't asked us to do anything yet with these discount prices, but I think that'll be later. Okay, okay, so got F. Okay, so F, a 5 by 2 matrix minus another 5 by 2 matrix. Okay, and that should give me a result, which is a 5 by 2 matrix. Right? Right. So we got 2399, 2799. Are these all after 99? Okay, these are all 95. Okay. Well, let's just go with it. I already started it. 3299. You're writing a lot of 99. 3499. Okay, this is 11799. 126.99. 135.99. 138.99. 143.99. Woo. All right. Now over to I got that matrix backwards, didn't I? Yeah. Well, what should I do? What should I do here? Okay, let's do this. Let's do this. Okay. Because I did swap the O and the F, their locations. That's what I'm looking at. Okay, because I wanted a difference that has mostly positive values. So let's subtract this off from what? From here's actually fresh home is right here. And so here we go. This will be all right. It's gonna work out. Okay, so I got 25.95, 28.95, 31.95, 34.95, 37.95, and 120.95, 124.95, 132.95, 139.95, 147.95. Okay. Okay. There's your F matrix, here's your O matrix. We're gonna subtract those and see what we get. All right, so 25.95 minus 23.99. Okay, 196. Okay. So I got 1.96. Right. Next row, 28.95 minus 27.99. 0.96. 31.95 minus 30.99. 0.96. 34.95, 32.99, 196, 37.95, 34.99, 296, 195, 296, negative 204, 32.95, minus 135, negative 304, 795, 9, negative 104, 147.5, 399, 396. Okay. Okay. So there you go. There's math done. And what's the interpretation? What does this matrix represent? Represents how much more expensive is the F brand than the O brand. Okay. And since most of these numbers are positive numbers, and in general, the fresh home is more expensive than Olsen Decor, right? But there are a few negative numbers, which means that the opposite is true. Yeah. So you got that? Uh, okay, and that tells you how to do this. But, oh, you know what? They never asked. Oh, okay. I was looking for another question on this. I'll do this for you anyway, because this is their last example. Right? They never said what to do with these coupons right here. So let me give you guys a coupon example, because that would have been a multiplication example. They totally forget that. Yeah. All right. 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 So let's say she wants to, let's just do one of these. Let's say use her 10% off sale on Olson. Okay. So guys, if it's 10% off, doesn't that mean it's 90% of original price? No price, right? It's the same thing, right? So if you get 10% off, I'm just going to take each price value and multiply it by 90% or 0.9. Okay. So let's do this for Olson. Olson, okay? So I'll take the original matrix of prices, okay, which went 23.99, 27.99, 30.99, 32.99, 34.99, 117.99, 126.99, 135.99, 138.99, 143.99. Okay. Decimals. Okay, okay. And I'm going to multiply that by 0.90. So multiply, okay? And I'm allowed to do a scalar multiplication like this. Okay? Maybe in the future, we might get to multiplying matrix by matrix, which is a bit trickier, but for now, we can do this. Okay? So I'm getting up with another 5 by 2 matrix. Now let's see what these all are. Let's go So 2399. I said multiplying everything by 0.9. by 0.9. So I'm getting 2159. I'll just round to the nearest cent. Okay, 2799. Looking at 2519. 2789. 2669. 3149. 10619. 1429. 12239. 12509. Whoops, I just 143. Yeah. 129.59. Okay. And these would represent the prices paid, using the 10% discount. All right, there you go. All right. Okay. So lesson 11.1, they were showing you what was a matrix, how to interpret it, how to write and organize these things. Uh, lesson 11.2, right, we've done some basic math. You can add and subtract matrices that have the same dimensions, and you can also multiply it by a scalar quantity.